Hi, so we have this problem here. N2H4 gas plus N2O4 gas yields N2 gas plus H2O gas. And the question says when 8 grams of N2H4, 32 grams per mole, and 92 grams of N2O4, 92 grams per mole, are mixed together and react according to the equation above, what is the maximum mass of H2O that can be produced? So the first thing we should always check for is if our equation is balanced or not. And over here, as we can see, you have 4 nitrogen on the reactant side, 4 hydrogens on the reactant side, 4 oxygens on the reaction side, and on the product side, we have 2 nitrogens, 1 oxygen, and 2 hydrogens. So since this reaction is a chemical transformation, there should always be conservation of mass. And that means the number of atoms on both sides of the equation should be equal. So now we should balance our equation. First, we can start off with balancing oxygen because we have 1 oxygen over by the reactants and 1 oxygen by the products. So over by the products we have 1 oxygen, over by the reactants 4. So if I multiply by 4 here on the oxygen side, then I can match the number of oxygens. And so if I rewrite this equation, that's N2H4 plus N2O4 yields N2 and 4 H2O. So as you can see here, we also changed the number of hydrogens, and when we sum up the number of atoms, that should also reflect that on the product side. So that we multiplied by 4, and then 4 times 2 is equal to 8. So now oxygens are balanced, we can check that off, but our hydrogens aren't balanced. So we can go back to the hydrogens on the reactant side and multiply by 2 to get 8, which matches the hydrogens on the product side. So remember, we never changed the subscripts, we only changed the stoichiometric coefficients in the beginning, in front of the element symbol. So I multiplied by 2 here, so there should be a 2 here. And as you can see here, we also changed the number of nitrogens. So when we calculated when we summed up the number of nitrogens, we have 2 from 2 different molecules. So we have 2 from the N2H4, and since I multiplied the H by 2, I have to also multiply the nitrogen by 2 because it's in the same unit. And so that equals 4, and we also have the 2 left over from the N2O4. So total 6. Now I have 6 nitrogens, 8 hydrogens, 4 oxygens, 2 nitrogens on the other side, 4 oxygens, and 8 hydrogens. So now we can see that oxygen and hydrogen are both balanced, they're the same numbers, and now we need to get this n equals 2 to n equals 6, and we can do that by multiplying by 3, and then that would be on the reactant side here. So let's check. We have 2N2H4 plus N2O4 equals 3N2 plus 4H2O. Let's sum up our elements on both sides of the equation, make sure they're the same. You have 2N2, which is a total of 4. Hydrogen equals 4 times 2, 8. Oxygen here equals 4, and you have 2 more nitrogens equals 6. On the other side, we have 3 times 2, 6 nitrogens, 4 times 2, 8 hydrogens, and 4 times 1 oxygen in this unit formula here to have 4 oxygens. And as you can see, the numbers all balance up. And so this is the equation that we can now start to do stoichiometric calculations on. Okay. Okay, the second step would be to understand the question, which is asking what is the maximum mass of water that can be produced. So since we are given the mass, we can convert that to number of moles using this formula of molar mass here through dimensional analysis, where we're trying to cancel out the units to get the desired unit by multiplying by a ratio of 1. So we have 8 grams of N2H4, and we want to turn it into moles of N2H4. And we have here this formula, 32 grams per mole. This negative exponent just means it will be under as the denominator. And so you have 8 grams and 32 grams per mole. To cancel out grams, we put grams over grams, which cancels out to 1. So you have 8 grams, and you can multiply that by 1 mole over 32 grams, which is this same thing as this written. The ratio is the exact same. So when we manipulate this to cancel out grams on both sides, grams here and grams here, we get the number of moles. And so let's calculate what that is. 8 over 32 is 1 over 4, or 0.25 moles. So now we know we have 0.25 moles of N2H4. Let's find the number of moles that we have of N2O4. Since stoichiometric coefficients are in moles, then we need to convert our units to moles. We have 92 grams, and we have the ratio 92 grams over 1 mole. So if we multiply that by 1 mole over 92 grams, you can see 92 grams over 92 grams, that cancels out to 1 mole. So that means we have 1 mole of N2O4. Okay, when these unequal number of moles are mixed together and react according to this equation, what is the maximum mass of water that can be produced? Okay, let's see. In order to do this, we will need to figure out what is the limiting reagent, meaning which reactant will be used up first and will limit the yield, or how much of the reaction goes to completion. We can do this by figuring out which one gets used up first. You have 0.25 moles of N2H4, and an easy way to figure out the limiting reagent is to divide by the stoichiometric coefficient here, which is 2. And when we divide that, we get 0.125. Let's do it for this N2O4. Divided by the coefficient 1 here, and we get 1. So out of these two numbers, this one is the smaller number, which means that N2H4 will be used up the quickest. So since we know we have 0.25 moles of N2H4, it almost doesn't matter how many moles of N2O4 that we have, because the reaction will stop at 0.25 moles of N2H4. So to figure out what 0.25 moles of N2H4 converted to water is, we can multiply by the mole ratio. So according to our stoichiometric equation here, our mole ratio between N2H4 over H2O is equal to 2, the stoichiometric here, over 4, the stoichiometric coefficient here, and that's equal to 1/2. And since you have 0.25 moles of N2H4, same thing with dimensional analysis, where we want to cancel out the moles of N2H4, so we are left with the moles of water. You have 0.25 moles of N2H4. You can multiply by this ratio, but we need to cancel out N2H4, so it needs to be on both sides of both the numerator and denominator. So let's multiply by H2O over N2H4. So that would just be this fraction or ratio flipped. So that would be equal to 0.25 moles of N2H4 multiplied by 2 H2O over 1 N2H4. And that is equal to 0.5 moles of H2O, since we canceled out moles of N2H4. Okay, so now we have half a mole of water. Are we done? No. The question says, what is the maximum mass of H2O that can be produced? Mass, the standardized unit, is in grams. So how do we convert moles to grams? By using dimensional analysis, cancel out by a ratio of 1 with the molar mass, just like what we did up here when we turned grams to moles. Well, we can do that by finding out the molar mass of H2O. So approximately the molar mass of hydrogen is 1, and the molar mass of oxygen is 16, and we have two hydrogens. So that means we have a total mass of 2 plus 16, 18. That is 18 grams per mole. These numbers can be found on the periodic table, where it is written in AMUs, and the molar mass is written in the units of grams per mole. So now that we know we have half a mole of H2O, we can cancel out the units of moles to get grams by multiplying by 1 mole over 18 grams. And this is equal to, by multiplying by 18 grams per mole. Remember, always check that the moles is on both sides of the denominator, and 0.5 multiplied by 18 would be 9. So now you have 9 grams of H2O. When 8 grams of N2H4 and 92 grams of N2O4 are mixed together and react according to the equation above, what is the maximum mass of H2O that can be produced? 9 grams. This is pretty reasonable and makes sense. So I would say we did a good job.